Hey everyone, welcome back. In this lesson we're going to take a look at the timeline panel. So right now I'm actually on my Twitter profile page and I'm going to use this as an example of some timeline recordings to judge performance. So the timeline panel is the go-to place for rendering performance. You know how we kind of looked at the network panel to see what resources are taking a long time to download, for example? Well, the timeline panel, you can actually record sessions and find out what records are taking a long time and why. And we're going to take a look at that in this lesson. Let's familiarize ourselves with the timeline UI. At the top we've got a few controls. I like to stick with frames mode, which is this one, where each bar is essentially a frame, but you may prefer this mode. We can clear our current recording, similar to the network panel, start a new one. You've also got filter options here, and this is very useful because this is essentially a legend, where the colors that you see as part of these records correspond to the label that you see here. When we record a timeline session, we can actually select portions of it by clicking and dragging the mouse, and just a single click will typically select one frame. Each one of these vertical bars you see is a frame. Within a frame, you can have a number of records. Now a frame is essentially something that the browser had to do to update your screen, and inside a frame, we roughly have 16 milliseconds to do all the activity we need. Why 16 milliseconds, you ask? Well, that's because if we're updating the screen at 60 frames per second, that's 1000 milliseconds divided by 60, 16.6. Basically 16 milliseconds to do all your activity for a single frame. And that's not actually a lot considering how heavy JavaScript is in some modern web applications. Within a vertical frame you have a bunch of records and all of those are listed here. You can click on records to see more information, but just to start out, let's select some frames and we get an overview in this nice pie chart of where our time is being eaten up. In this it's very clear that painting is taking significant time, but I want to actually start a fresh recording, so I'm going to clear, start record, scroll a bit, and stop recording. It's important to keep your recording short, so what you see here isn't just noise. I'm going to select one bar which clearly blew over our frame budget, and also keep in mind this is a powerful machine, and I'm going to scroll down these records to find out what's going on. Now we know paint is what's taking time, so let's have a look at this paint record. We can open it up and we see an image decode. Now this is kind of insane when you think about it. It took 22 milliseconds just to paint an image. Now what image could that be and why did it take so long? What's really useful is we get the exact image which caused this issue to occur, and it's clickable. So let's click on it, and this is interesting because this is actually my fault. I posted this tweet a while ago. I think I was showing how you could copy the stack trace of call stacks when paused at a breakpoint, and if you look at the bottom you'll see that the dimensions are kind of ginormous. And now it's starting to make sense at what happened. When you serve the browser a very large image, it has to do a fair amount of work to resize it, and that's exactly what's happened here. What's really cool about this details pane is we can even click on the image element and be taken to that DOM node in the elements panel, and if we want to find where it is exactly, we can right click and scroll into view. And there it is. I'll go back to the timeline. It's not just painting which takes time, it's also JavaScript, and that's typically seen as yellow records because remember, yellow is scripting. But instead of Twitter, I want to show you a different page. So here's a really cool jQuery plugin on the CodDrops website, and the idea is you have this image and you can click onto it and zoom and it does this like amazing effect, and I really like it. But let's find out how this performs. I'll open up the DevTools. The screen is positioned in such a way where as soon as I hit record I can go and do my action, but keep in mind you can also use the shortcut Command E to start a recording. Well, we can immediately see that 17 milliseconds was spent on scripting. This is kind of a big deal. Again, when you consider this as a reasonably powerful machine, but more importantly on mobile this isn't going to perform well whatsoever. So we're after JavaScript activity which occurred after the click, and we can see here that there's a click event and it's got a little faded out triangle. If we open that up, you actually get triangles which are more coloured, and basically the idea is if you see a faded out triangle, that signifies that this parent has children with these warning icons. Now here's where it gets interesting. We'll click here, and as you can see the details pane is full of information. We can actually see the entire call stack of what triggered this record to occur, and this is extremely powerful because we can basically drill down. And when I say drill down, I mean go to the line of code which caused that record to occur. So if we browse through this, we see a lot of jQuery activity, and then we start to see some possibly website specific code which should hopefully indicate to us what is causing this record to occur. So I'll click on this zoom tool and I see it's calling an apply style. I'll go back and I'll do the one right above jQuery.transform. And what we can see here is this method called apply style was called. And if we do a search for the definition of this, we can see that it's calling jQuery's animate or CSS function, both of which have caused a layout to occur. Now when possible, and keep in mind it's not always going to be possible, you want to try constant reads and writes to the DOM. If you can, batch those up, read from the DOM, get the source of truth right at the beginning, and then do your writing. If we scroll all the way to the bottom of this pane, we even get a little warning. Force synchronous layout is a possible performance bottleneck, and this is basically saying that this record right here is synchronous. The browser has to stop what it's doing to lay out the items on the page. But again, don't get me wrong, that's not to say that we shouldn't be doing this, it's just understanding the problem of performance is half the battle in my opinion. Let's go back to Twitter. I wanted to show you a little tip. If you find that, for example, paint records are taking an unusually long amount of time, head over onto the Elements panel and find an element which you think could be the culprit of all this. Now I'm just messing around here, of course this isn't a stable solution, but let's make a new selector with image and cause it to display none, and I'll probably have to important that. Okay, now go back to timeline, clear and start a recording. And I don't know if you noticed, but these frames are occurring a lot quicker, which is good. So the thing that I wanted to highlight there was you can go to the DOM tree view and basically hide elements. A shortcut to do this is to select an element and hit the H key. As you can see, it applies this Web Inspector hide shortcut, which gives it a visibility of hidden. This is useful for really finding culprits which are contributing to poor performance of your web app. So to recap, Timeline Panel is great for the render performance of your page. You've got a few controls here, always clear and then start a fresh recording when you want to analyze things. You can use filters and the legend to understand what's going on, and you can toggle these on and off should you so wish to. Vertical bars are frames, and within a frame are records. You can single click on a frame and that will give you a pie chart and a little overview of where the time is being spent. You can click on individual records and that will give you further information. And in the case of JavaScript, like on the page that we saw earlier, we even get call stacks of the exact line of code which caused that record to execute. That's all for now, I'll see you in the next lesson.